This is Godot, an open source game engine. It helps me make cool stuff like this, and like this. Games use a lot of math, so let's talk about some of the most common mathematical concepts you'll encounter in games and how they work using my project Spellbound as an example. This is a duck. Let's imagine this duck is an item in a game, and we want to indicate to the player that the duck is something that they can interact with. A common way to communicate that to a player is to animate the item floating up and down, kind of like this. So how would we do this? Well, consider a graph, where x is time and y is the vertical position of the duck. If we had to go in and tell the computer to move the duck for every frame for the entire duration of the animation, it would be painful and take forever, even for something as simple as making a floating duck. So, how do we actually make a floating duck? We tell the game engine where we want the duck to start and where we want the duck to end, and the game engine can solve for the in-between part. This method is called a tween, and it's incredibly common in any kind of animation. So what does this kind of animation look like in Godot? It looks janky. The snapback is kind of harsh, so let's fix that with a pong loop. That's better, but it still feels unnatural. Let's fix this by changing the kind of interpolation we're using. Interpolation is a method of using known data points, keyframes, to estimate new data points. So far, we've been using a linear interpolation method, which estimates a straight line in between the keyframes. Depending on how we tell Godot to estimate these data points, it will change the feel of the animation result. For the purpose of making our duck feel floaty, let's use a basic cubic spline interpolation method. Don't worry, we don't need to calculate anything. Godot will do all the mathing for us. The cubic interpolation method smooths out the movement of the duck, giving us the floaty feeling that we were looking for. This is the main menu for my game Spellbound. I really like this bubbly effect that my menu has, especially because I don't have to animate it myself. So how does it work? I have two textures, a linear gradient and a cellular noise texture that Godot combines to create the effect. For each pixel on screen, Godot takes the same pixel on the noise texture and multiplies its color value by the position on the gradient texture. If the result is higher than the specified cutoff value, that pixel is made fully opaque on the screen. Otherwise, it's made transparent. The noise texture is then moved slightly, which gives the effects of the shapes shifting along the screen. If we change either of these textures, we can change the appearance of the effect. Here, we've changed the shape of the cellular noise to something a little bit sharper. Here, we change the cutoff value. Here, we change the shape of the noise again. And here, we change the shape of the gradient texture. Mathematically, it's not overly complex. Change the input variables and Godot handles the rest. What I love about making games is creating interesting effects and experiences for people, even if the underlying concepts are simple. If you find something interesting in any digital media, see if you can learn how they did it. Chances are it's simpler than you thought. And if it's simpler than you thought, why not see what you can make with it?